Hi. So today we'll discuss about the LLD. So what is LLD? It's a low level design. Low level design. Okay. So let's take one example and we will solve that problem with the LLD. And I will write the code in TS. So TS is TypeScript. I use TypeScript for writing code. So I will explain the thought process. Then I will write the code in TS. Okay. And then I will explain you like what the problem we have solved there. Okay. So, so like we have one question. We take one question where we will work on the rate limiter. Okay. Mm. Today we will work on rate limiter LLD. Okay. So how they can ask you this question about rate limiter? First, they will ask you like design LLD which limits 100 requests in 1 second. You can say that allow you have one system, we have to design one system with the LLD which allow 100 requests per second. Okay, so at 1 second you can max give 100 requests. If you are exceeding more than 100, then it will show error. Okay, like you are not able to exceed this again. So what are the functional requirement we get? Functional requirement. Okay, so let's talk about the function again. So what we get from this question? First thing, what we have to do? We have to make system which allow 100 requests per second. Okay, per second you can say 1 second. Okay, I think my writing is not good. This like make it more good. Okay, okay. So allow 100 requests per second. Okay. What will the second requirement we have? So if you think of the question, like how we will limit this request? We have to know something. We have to know something to limit this thing, to limit the request. Okay. So we have this person. So what, how we can limit this? Like for user, what can be the, we limit with the user ID, or we can limit with the email. All user have different email, or we can limit as, and you can say IP address, their IP address, you can limit. So there are many ways. So here we'll use user ID to limit the user. Okay. So let's change this. So what I have said, second requirement is with the user ID, they have to limit the user ID to limit the request. Now, what will the test is? Okay, so we have one features like 100 requests we can pass allow. We need a user ID, so we need to store user ID. Then what we need? So if it's exceed that limit, then what we do? We'll pass some request. So we have to handle if it exceed this limit, we provide notice that you have exceeds your limit. For an API, generally what we use 4 to 9. Too many requests, which too many requests. Now, so first we have to like allow the request. Second, what we get, we need some user ID to know like how many requests user had done till now. Second, if you hit the limit, then we have to provide message like you have hit the limit and you have to wait for some time. Okay. Now, fourth, what can be? So, if you think of the fourth will be like when we will allow again. That's main question. Like one more thing which we have to handle. So we have to handle after 1 second, we have to allow users. Okay, because it's not like this. Like if you have user repeat once at 1 second, it will get 100 requests. Then he try to hit at 1.1 second. Okay, just 1 second and 0.0 mil. You can say 1 second and 1 millisecond. Then you have try to use it. But after 2 seconds, you can hit two API, two requests, three requests, four requests. So you have to refill this. So you can say as refill the token. Okay. So I think this code functionality, which I think is useful for anything new. Let me see. So we have LLD request exit is limit. We provide the message. Okay. We will just allow. Then if we allow what we need, user ID. If we have user ID, then we have to exit the limit. Okay. And then after 4 seconds, we allow them. Okay. So the killing and okay. And so like for currently, I think this things is more than sufficient. Now we will go to the non-functional requirement. Okay, it's not this way. Let's try to use black on. Okay. So now we use non-functional requirement. Non-functional requirements. Okay. So non-functional requirement. Okay. First we have low latency. We always need low latency means like how fast your API should respond, like how fast you're getting the output. So it explain low latency means how fast you get the response. Yeah, how fast you get the response that is equivalent to the latency. Okay. So if you need latency, low latency means like you can get the request fast. What we can use? So just think of the like what we are doing in functional. We have something like user ID. Just yeah. Just think here. You have some user ID. We are storing how many token he has. That user ID. If user ID is one, then it's have how many token you can see 50, 53. So you are storing. So to get the data, like at any point what you're checking, if you are working on any process, like you will check, okay, I will check at one how many token, okay, and then if it's less than what the maximum, if it's greater than the maximum request, we are not allowing. If it's lower, any lower we are allowing. Okay. So I think to fetch that data from the memory, what we can use? We can use map so it can become fast. So for low latency, we are using map, okay, because it will give in order of one. If you want any data from map, it will give an order of one. Like if you want, you have some array one, two, three, four, and if you store at zero index one, one index two, two index three, three index four, you want at index two. You can say as a map to what we have. We have three. So to get this request, we are taking a order of one time. Okay. So for the latency, you are using map. Now another thing. Now we have so what this means. So what means like if you say so, so what means like how we handle large amount of requests. Say if you are using any website, okay. So it is not usually like you are hitting and another man is not hitting. It's waiting for you. Then if you hit and another man hit, it doesn't know about them. So this is we call it traffic. Like how many users hitting that at that time. So maybe user one will also hitting same request. User two also hitting, three also hitting, four also hitting. Okay. So handling that we call as throughput. So handling them we call as a throughput. Okay. Mhm. So, like handling the large amount of requests, we call as a throughput. So it should be high because we want maximum customer can use our website. So for that, what we use? So for making the rate meter, we have two methods. One is you can say token bucket, and second is sliding window approach. Sliding window approach. So we have two approach. One is token bucket and sliding window. So let me explain one by one both. So what will be the in token bucket? So I will give you the example what we do in token bucket. So in token bucket, like we have some bucket, with the name you can suggest there is some bucket. Okay, we are filling with tokens. Okay, so token mainly means like how many requests were allowed. Token here means request you have, request to allow. Okay, so you can say like at 1 second you can allow 100 requests. Okay, and every 1 second you are again allowing 100 requests. So user come. Okay, so user come at 100 and then it will you have it will check like how many requests you have. So you have 100 requests, user come at 1 second. You have 100 requests. Okay, and he is hitting 100 requests that time. That time he is hitting 100 requests. So you were exhausted. You just use that 100 requests. Now in bucket you have zero. So now if user try with 1 second and you can say 1 millisecond after that. 1 second plus 1 millisecond or millisecond. So we have exhausted all our token. So what we left with zero. So what user do? It do nothing. So if we have one, you can also one request if you are putting, it will not take you. So what it will do, it will not allow you to access that API. Let's suppose it, like one, we'll take one more example to understand this more properly. Okay. So let's suppose you have a rate of filling the token. This is bucket. You're filling bucket every time. Like after 1 minute, you're filling 60 requests. So okay. So user first minute user come. Okay. He hit 4 requests. So at 1 second you have put 60. Okay. User come and it will take 4 requests. Then how many we have left? 56 requests you have left. Okay. Now at 1 minute, 40 seconds, user come. Okay. And user will see how many requests left. So now we have 56 and it trying to request 50 requests. So you have 10 minus, then we have 46 requests. Now we have 56 requests. Okay. So let's suppose at two before 1 minute, you can say 55 seconds. User come with 46 requests. It will come and it will decrease this and it becomes 0. So now in bucket, you have 0 requests. Now if the user come at 56 seconds and hit the API, you can say it's one request only user want to hit. He will not able to hit this because in bucket you have nothing left and bucket will refill after every minute. So till now we are not reaching to 2 minutes. If we reach 2 minutes again, then it's become 60. Then again it refill at 60. Now if we hit 1 minute, 1 second, you can say one request only, it will allow. And how many requests we are left? 59 requests we have left. So what token bucket approach explain? You have some bucket. Every time you are filling that bucket, maybe you are filling with some rate. You can say 1 minute 60 requests or 80 requests or 90 requests. Any or per second you are filling. You are filling that. Okay. User come. It will check. It's on bucket. Requests are there. If requests are there, it will allow. Otherwise, it will not allow you. Okay, so here it allow, here it allow, here it allow, here it will not allow, but here it's allow. So this is the token bucket method. Okay, now we will go with the sliding window. Sliding window, explain sliding window approach. Okay, so in sliding window, what we do? We make a window of that size. So if you have 1 minute and you are allowing 40 requests, okay. So we have box of 40 is 0 to 39, which is a 40. Box of 40 and it will store that time span. Store the time span. Okay. So let's and it always calculate that window. So see if your window line at 1 minute, 40 requests if they are allowing. Okay. So what so if you're at 1 minute, we take you can say we just hit 20 requests. So you're user and you're using it 20. You commit 2 minutes. So what will happen if you are requesting 40 requests? Let's think of this. So what I'm saying, like in sliding window, we always calculate the window size. So window size will be the always a maximum request, which is 40. And how we fill this? How we'll fill this? So it based on like on last 1 minute, how many time we have visited this request. Okay. So let's suppose at 1 minute you have requested 20, 20 requests. So you fill till 20, so till 90, every cell with the times, you can say at 1 minute. So I will put as a minute. So I will till 19 minutes and remaining are the series will do. Okay. Now if you come here at 2 minutes, okay. So what we see, the difference between the 1 to 2 minutes. Okay. So till the interval 1 to 2 minutes, have the user visited this API? So now it becomes empty of 40. Why? Because at 0 to 1 we have visited this. But when we come to 1 to 2, okay, so there is no time which is greater than which will include in this window. Okay. So is there time? Okay. So I am saying this. So at same time at time span 20. Okay. I fill with till 91. Okay, so at 1 minute we are showing the time span. So it's a 1 minute. So we come at 2. So we'll check in this interval of time we have visited this API in this interval of time we have visited this API or you can say request. We have visited or not. So we have visited no. There is no greater than 1 and less than 2. So it should be greater than 1 and less than 2. So we are not visiting. Again, my window till 0 to 40 because maximum we are around 40. Again, fill with what it will fill with 40 requests. So it's 2, 2, 2, 2, 2, 2, 2. You got my point? What I'm saying? See, what are main difference in the token and the starting window? Here you can see we hit at 20, 40, sorry, 20 requests at one time. Now this space is left. So we left with the 20 request. Again, if you come at 2 minutes, we again fill with the 40 requests. We are not filling with the 60 requests which come with this. We are not taking on this. But if you are using token base, if you are using token base, which is this, so what they do, if you are using 20 requests out of 40, it will store 20. Again, if you refill with 40, then again you have 60 requests to do. So token store the token, how much you have spent and how much you have left. But sliding window will not store. It will just calculate the window timing and it will store that much request with that respect of time. Let me explain more clear about this sliding window. So let's take, if you say I want to create some good interval. So you get explain more. You can say, let's go with second. At 3 seconds, we are allowing 4 requests. Okay. So at 1 second you come. Okay. You have 4 requests, so 4 boxes there, 0, 1, 2, and 3. So at 1 second you say I will hit 3. Okay. You hit the 2. So it will be 1, 2, 3. Now we have one remaining. This is the sliding window approach. So at 2 seconds you do nothing. 3 seconds you do nothing. Okay. Now at 4 seconds you come again and you request 2. So basically what the sliding approach is doing and what is a token based window. So I will just explain the sliding window approach. So at 2 again it will come and it will calculate the 3 second of interval. So 4 minus 3 which is 1 second. So in this interval from 1 to 4 second, okay, which means the time span should be greater than 1 or less than 4. Have you visited this API? No. This is the box. So 0, 1, 2, and 3. How many limits we have? 4. No. So it will just allow, they will allow the 4 request. Okay. But what token base will do? Token base will reveal this thing. Like if you say at every post request allow after every 3 seconds. So what token base will do? At one, you have three requests, four requests, sorry, and you have used three. So you left with one. You left with one. Now at 2 seconds, it will not do. At 3 seconds, it again refill with four, which is five. Now again, if you come with two, it will take two and three. See, here your token is safe, but here in sliding window, your token is not safe. You got my point? You understand this thing? No? Yeah. So this is the main difference between a sliding window and the you can say token based. So that's why we are not like if you are using some security purpose, we are using for security purpose, we are using sliding window. You can say OTP verification if you are using and token bucket we have. So if you ask like if you are asking to use the high throughput, which you will prefer? I explained both things. Okay, so I'm asking like which has so this is not visible. Let's take some dark green. It's good. So it's a let's move slowly. High throughput. So throughput I explained like they can handle large amount of requests, large amount of requests. So I think which you will prefer, token based or token bucket. First is token bucket, and second is what you can say sliding window limiter. Which one you prefer and why? So I think the answer is token bucket system. For this, I can think also token bucket system because it does not lose your request. Like when if you're coming, if you're having some request, it become add up. Both are valid, like but I think token based will be more because our token is not lost. Like our request to access, if you are not using at some point, then it will add up and we are getting some other benefit. So for that, I think token will be preferred for uh, with the sliding window limiter. Okay. Now again, what we can say memory management. We have one more memory efficient or management. You can say. So which one is good? So I'll explain you token bucket and sliding window. Which one is good? If you think about the memory efficient, like which one will have better memory management? So in token, what we do, we just come and store the value. Okay, we just have one bucket and that is store the token and we'll get the value. Within sliding window, we first calculate. So calculating, we need, then we are making window. Okay, and then we are using time span, valid time span of that. So we have token and this one. Okay, which one is efficient in the memory? Yeah. So we talk about the memory efficient. So suppose explain the suppose like we can use token bucket because it will store the data and the data we need to calculate them is less. Like for token what we need just first last refill when we refill it last and refill rate, that's it we need to calculate the value for token. But for the sliding, what we need, we just we have to store the first time span, then we have to search that time span should be greater than that windows. So it will take time. So put handling the large amount of requests in low, how we can do? We just use bucket. Because bucket, if you come, you have token, take it and go out. But if you're using sliding window, you have to first store the value, then we have to check if it's greater than the time span or not. If it's not there, if it's there, then you have to refill this with that time span, and then we have to give the return. So it takes memory and takes more memory. So for memory efficient also, we can use token based because we don't need much things. Token based, if you are, we need at any point what amount of token we have. We have some refill rate, which I have said like how many refills the refill allowing per second, which is can be as a refill rate. We have token and last visited. When we have last refill, so this this will give you the refill. When you refill, then if you refill rate, if you can say multiply by this time second, or you can say milliseconds. That if how many token you have, like I understand, like if you're using one token per second, so what you do, you just multiply with the second, so it will, you have one token at 1 second. So anytime what amount you need, you just want to store this refill rate and last when you have refilled this so that we know how much token you have left and token. But if you go with the sliding window approach, you have to store the time span, which will be the large value because you are storing at ms, or you can say you can store as s also, but mainly I will get lowest unit of that part. So ms, so it have large value. Okay, so storing at ms, then we have to call the filter which has greater than that time span which we have calculated, and then like if it has window of 1 minute, then if you are searching at 2 minutes, so we have to check which is greater than this difference, so which is one, and then we have to filter out. Then we have to mm, we have an array of maximum requests, and then we have to refill this, and then it will have we have given the result. So in both the throughput, because throughput I have said like handling the large amount of requests. So for that, what we need better? It will be token based because we have less memory usage and fast operation will there. You come, you know it's there, then you just exit out. Here, come, check valid time spent, then check again the how many requests you are needed. in that array you have, then you are allowing it. And so I explained memory efficient also, like here what we need. We just need an important token, how many token you have. So how you can get this token? So you can use some bucket where you are storing token. Okay. So per user, how many token you have, and when you have refilled this. So for that you can get like how many token you have remaining, and we will add up that one. So I think this one is more memory efficient than this one. Okay. So I explained the outputs. Let's explain one by one from the start what I have done. So we have to explain LLD, okay, which is a load design. Okay. So I have asked you to design an LLD which limit 10 requests per second. So at 1 second, you are around 10 requests per user. Okay, so per user, you okay. So, so from that question, what we are getting, that is the functional requirement which we can. So we have things like 100 requests per second we are allowed. Then we think like we need user to limit the request. So what things we need to limit the request? User ID. Then if we exceed the limit, what we provide some limit exceed. Or you can now put you can add allow as a false. After that, we have one after how many times we can refill it. So it's saying after 1 second, you are again allow 100%. So again, you allow them. Like you are not blocking them. Again, after 1 second, they can request 100 requests. So non-functionality requirement, what we have learned latency. Latency means what? How fast you get the request. So how fast? So if it's a minimum number of operations, then it will give you the fast request. Okay. So if you're using map, so mainly what we're doing, we are storing user with how many time they are using any. Like if you're using token bucket or sliding window. Token, how many time they have on token bucket, how many token they have at that user ID, and on sliding window and last visited, and then sliding window, how many when they have visited, we are storing them. So you just recording on the map. So both, if you are using map for storing the data, we can fetch on big of one. So for your latency, you're using map. So height throughput means like handling the large amount of request at any time. So which one is better? Token bucket or sliding window? So see, in token bucket, what we do, we come, we have token, we allow them and go. But sliding window, what we come, we check. We calculate the window size again. Like at this window, like from what if you are saying like 50 requests at 1 minute, so you are checking at every 1 minute, and you come at 2 minutes, then it from 2 to 1, it will checking like you have any time we have visited that request. No, if no, then you are filling that with the valid, and then you're just returning true or false. So it has taking memory as well as have more operation than the token based. So I think this one is better than token bucket is better than sliding window because it has less operations. So it will give the request faster than the sliding window approach. So then I will explain the token bucket. So in token bucket, what we do? So I said like it's a bucket, and every time we are filling that bucket with some like if you are around 60 requests per minute, so you are filling every time bucket with 60 requests after 1 minute. And after if you're coming with so if you come at 1 minute for the request you're taking, then again you are coming at 1 minute. So you're taking when it's exhausted. But if you are not using that time, you can say ideal time, then at that time this time it will automatically add it to your token. Okay. And this is a sliding window. We just take the time range. So if it's 1 minute, so we'll take the last previous time range. So from that time to less the time range we have to calculate from what we have given. So it's given as 1 minute. So we take a 1 minute interval. In that interval, how many requests we are allowed? 40. So we will make a array. of 40 and we store their time spent when they have visited. So 40 requests is visited. So we mark the 40 the time spent they have visited. Okay. So this one I have explained. This one is so good. Then next one. So let's explain all the identities. Identities like what are we are using. So if we go with token, okay, and if you go with the sliding logic, what identity we are using. Okay. So token we have some bucket. So you're using some bucket. Okay. Bucket will have token, which will be our like request, and what other things token will be the number of this, and what again last refill. When we have refill, so from that we can calculate what is the remaining we have. So refill we can take as a number. Okay. Now, what other things we need? This is the bucket we have. For bucket token bucket concept, the operation which are performing inside, what we need refill rate. Okay. In that we also need bucket to store the data. Bucket will store this data. So we are using map. You can see this. So we need bucket to store data. This is a bucket type. In bucket, what other entities we have? And we need, you can say buckets, which will have this interface bucket type, and this will be the map. So in map, what we do, we need first string, which is a user ID. We are using the user ID and then the bucket. Sorry, this is the bucket. Let me write it to else. So we need some bucket, which is equal to map. We store user ID, which is a string, and we will store bucket. Okay. And like for process which we are doing on token bucket, what config we need? So token bucket config. So let's think of it. And we need something for refill. So refill rate, you can set refill rate. It should be a number because we are saying that 50 requests per minute. So it's a number 50. 50 requests per minute. So it's a number. Okay. And anything more for processing token we need? Let's check. So we have bucket. Let's say this. Mm, So bucket. We have this. Would have, mm, and we need maximum request to identify like what is the maximum request they have. So one more we need maximum request, which is also a number. How many maximum requests we have and we will wait. Okay. So these two things we need. Okay. When we have token bucket. But when we have sliding window, what we need time span array. Time span array we need. Then what we need? We need bucket. No. This bucket we need to store. So in bucket, what we store, which is a map, new map. We store string with the user ID and again what we use? We use time span, this array to get like valid the time span. And like inside what we can use the sliding window config. Here what we can use subset like what are the things we need. Here we have window, so bucket we are using. Then we have window size. So window ms you can say as window size, which is also a number, and maximum request we need maximum request. Here also we need maximum request to decide like it not exceed the maximum request. These two things like the technicals which we noted. If we're using token, we have buckets. So what bucket should have token and like what last we fill. So we make a bucket of every person. So we use a map with this one is a user ID and this is the bucket, which have two things, token and bucket. Then we have config, which is number and maximum difficulty. And if we are using sliding window to solve this, we need some array of array and then this map and then maximum represents window size, which is we can ms you can say. So these are the things which we need. So we code this one. So let's take to something compile it. Yes, compile it online. Mm, I will divide this thing so you can able to understand this. So first we will implement token. Okay, then limit. And say limit. Okay. So what I said, I need bucket. So interface bucket. Okay. In bucket, what we have token, which is a number. Then we have last refill. Refill, you can say as a number. Okay. Now what I said, I need bucket. So you can say as a bucket. Okay. Okay. What is now? Some map string color. Okay. Okay. This is map. We can map. Now we have token get config. Okay, for this what we need for maximum request. Request number. Then we have let's go with it. So that's one. Okay, so we have this thing. So interface. Interface. Okay. Now we will define our class. Open one bucket limited we can use. Yeah. So in that we have some private elements of bucket. We can define buckets, which buckets and buckets, which will have the type buckets. Okay, which is equal to the new. Now, so yes, it's not different. So we'll define the map. Okay, now what we can do. We will define constructor which will have the value which will have what maximum request. When we do this, we will define the maximum request, which is the number. Okay, then we have private, it, which is again a number. Okay, and this. So define the construction. Now we have allow function, which will allow the request or not. So in allow, what we are getting, we pass user ID to what user ID will string. So for returning something, we use boolean. Okay, set now. We have to find the time. So now, so what we will take dot now. It will give you timing ms. Time ms. For power, let me check also that now okay, so it's doing and ms. Okay, so we can say I using per second request. Can you request per second? Um, okay, so 100%. So if you're using second, so I can divide, we have to divide with 1000. So we will return in second. Uh, Oops. So no. So we got like our time. Then what we first the data. We come bucket what we. So choose open details. Just so how we can calculate this? So we have this like bucket like but okay pass usually. If it's not there, the input kind what we're using we take as a token as what you can say so that's so it's empty. So we take as a maximum request and what last level. No. Okay. So what I'm saying, like if its bucket is empty, then it's become undefined. So I will take this value and then I will return. Like I will take this one and more. So I got user details. Now I have to find the token we have. So after spending how many token we have left, left token. So how we can find? So we can use minimum to what we with. Okay. So user come my minimum. We have token. So what token we have? Mm, This this like this dot bucket dot so how you have so you would use it. It is like token okay plus how we declare it. So we fill this dot declare it plus this dot equal enter that time equals so how many time we have spent till now. So when we are hitting now minus last repeat. So for user we need last repeat minus user token dot first token. Okay. So what we have maximum request how many have minimum this. Like if we have left with maximum request we have. Okay. We just refill and like how many time price lips. Then we got how many more. So we have request to four, you can say four and we have constant left token. So this one is like if you take the example, this is 40. And this will give like whatever left is. So every time we are getting the minimum of this, which will be the left token we have. It's not like we're taking like we have used 20 before. Now how much we have left with? We left with 20. Okay. So we are using token. Which option we have bucket. So first we have 40, we use 20, then how left, then again we have 20. So maximum is always 40. This one will give the refill. If after sometimes we refill. So let's suppose we have 20, user use 20, but after 2 minutes, this minute will do it. So after 2 minutes, it will again get 40. So refill is 40. And then this is the difference of this. So if it's 1 minute, then it will again 40. So we got 60. We got end of this. Then we have to wait a minute. So 60. So we can allow 40 also. Okay. We can use that. Yeah. So we have minimum this. Now what we do? So if left token is greater than so if it's greater than then we can allow. So return true, which means we are allowing, but before returning we have to set that in bucket based on bucket dot set what user ID first and then token will be how much token we left with. We have token and now we are using one, so we decrease with one and last is okay. But this one different. But if we are not okay, so if it's not greater than equal to one, so we are not left with any token. So what we do? Just set get to set what we set. So user ID token will return that token same, but we have visited it now. So last cycle is now. We check it now. And we return false. So that all the error like error will run. So what we took bucket, then we storing bucket, then we token conflicts bucket constructions, allowing which is a method which allow you to have you in the limit or outside the limit, so which allow will do. Okay, so this is the code. Let's check like it's correct or not. Okay, so we will create an object. You can say um, API method. So what we do, we object token bucket. So first one is maximum is you can say 100 and they will per second. So they will wait, okay, which is 100 per second. Okay, take it low level to explain better. So I can do maximum request and it will every minute. This one will become 8. Okay, right? So multiply with the transfer, then we will get the all token we have. Now we'll check at 1 minute, at 1 second, we have 3. Okay, at 1 second, we have 3. So I will try after 3, I will write this input and we will explain it. So I will allow with user ID, you can say user one, which is a string, so I will take user one. Okay, now, so it will allow three to request, after that please will be give false. So I will try one more thing. I will run one this function again after 1 minute, 1 second, sorry. So let's do this and we will check what output we are getting. After 1 minute, it should be give the allow this. So let's approach 1 minute. I think 1,000 is 1 second. Check my wallet. Yeah, 1,000. It's good. So after 1 second, you this one will true. Then this one will give false. This one will false. This one will again going false. It should give true because we're trying after 1 minute, 1 second. So after 1 second, it should be again repeat and then this one they also will false. So check. See, one derivative true. It comes after sometimes. So you can choose some other words. So this uh, after 1 second. So let's send this. Okay, let me clear. Yeah, let's send this. So let's see. First one give true, true, then it's false, 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 false. And which one we have allowed after 1 time? We give. So after 1 second, again it refills with true. So we have token 10, it will allow. This is a code for token bucket. We are using map. We are using map request. We will wait. We are refilling with seconds. So this one give millisecond. We just divide it by 1,000. So it will give second. Okay, we just get the data. And so if they ask you like how, so this one you are not able to use in production. Then production, what you can do? You can use Redis. So Redis will help you to store the data, fetch from the data, store these values with the users, and trace the data fastly. So for production level, we are using Redis. Use Redis. Okay, so instead of this bucket, we are using a Redis, and we make the client Redis client. Okay, so below also I can explain you the code of sliding window. Let's go with sliding. So sliding window. So what we need first, we need some array, we need types, and type is the time span. Which is what the time span. It's a array. Then what we need, we'll check. Now we have the code. We need bucket, and then we need sliding window. So we need buckets, so we need the type. Buckets, buckets. What we do, we need to map map, which is a string, and then times. So let's type change interface. Okay. Now we need interface of sliding slide. Okay. So this is sliding window complete. What we need for example it's which is a number. Okay. Then we use let's interface unit and we need what still this Windows OS, which is Windows MS, which is a random number. This is a Windows, this is a Windows. So so we just define class, lighting, window, we can use limiter. What we do? We need bucket first. So those buckets. Okay. So buckets will add what config. It's buckets. Okay. Now initially we can slice with because it's empty. So we can slice with map. We inside with command. We call constructor. Constructor will have what? This maximum request. We have to define whenever we define this, which is a number. And again we have private window plus which is again number. And this one is okay. Now I write the function which take the user ID because we are behaving user ID and which is a string. Okay, so this is a string. We calculate the time up now. Now it will be 8. Now I've said this will be in MS. We are building in the MS. Okay. We need cut off just a second. We need cut off time. So we decide so what is the cut off time. Mhm. So now this dot window is will cut off time. So we need valid. First we need visit time span when they have visited time spans you can say. So when they have visited, or you can find you can use buckets. But no, we can directly don't use bucket because I'm telling you it's like maybe the bucket will and it's user details. So what you do is dot bucket dot get user ID. Otherwise we have this. Now you can use filter. Filter you can say that we have time. Let's take it time. What we return is get return. We will get this. So we will do when we are doing when this page is 10 of length is less than this dot next in the first then we will okay. So when we're doing what we do, we return span, we push the time span, which is now we push this. Mm, mm. Now we will set in the bucket. Just press in the bucket. Bucket dot set what we have to use title this now sorry damage like but this one being the user times because we can say okay valid people factor valid times valid times okay and then the return if it's not there then again we have to set this set the user ID and then user valid times now okay and then we do return oops, okay so this is the person just a second I've seen and we will call all of this okay by using sliding So this one is the maximum request, and this one the window size. So this is in the MS. 1 minute, second, and 1 second. You will then add 1 second you allow that maximum full request. Let's check it. Okay, request. Same thing. Window. Okay, this another. There is standard. It's okay. So then we set details. Okay. Let me create the log. See, same result over it. So use window of 1 second, allowing maximum two input. So first two were true, second, third were false, 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 false. And which I have put after 1 second, it got true. So you have seen this two sliding window lantern and this one, token bucket limiter. Okay, reactive time span, the math, and sliding windows, the constructor, then we have to find allow method and this allow method. So this is the approach we have to have rate limited, and I think this will be better. So for this also for storing bucket, instead of bucket, you can use Redis for production level, and for if you they are asked about the scalability, if they ask about the scalability, you can use Redis for the scalability, and that's so this is the end of this video. Okay, I explain you this code and how you can do this. I explain everything, how you get like from functionality, non-functional, then which approach you are doing, what is low latency, what is throughput, and I explain both the process. I explain with the code also, like what we are doing. So why we use high throughput and why it's more efficient, what identities we use, what data for storing we use, and describe this. And I have given you the like I have given the code, this bucket maximum. So this will go MS. So here we're storing as a second. They will rate as a second. Okay, so that's why I convert into 1000. Detailed data, how many time we have the left, like rest. So rest will be below, and this is the how we build the whatever left things. Okay, and this is token, and we get this for same. We are getting both the same result. Okay, but when the large amount of data is there, so it takes more time than the token method. So that's why we're using token bucket method. But if we are using for safety purpose like OTP verification, we are using this one. Or like email login page authorization, you can say.